Hello everyone, let's start with chapter 6, ratios and graphs of trigonometric functions. So we call as trigo. So trigo is quite challenging, but I think we try to go. It's okay, it's actually not that difficult, it's just that you need to be patient. So what will you learn for this topic? The value of sine, cosine and tangent for the angle theta. And the theta is from 0, inclusive of 0 to 360 degrees. One circle. The graph of sine, cosine and tangent functions. So the graph is quite interesting. Alright, why study this chapter? Engineers use the graph of trigonometric functions in the construction of concert halls. Okay, so to measure sound strength so that sound is clearly heard. Sound. Geologists use graph of trigonometric function to help them understand the formation of periodic pattern of earthquake and waves. So that means trigonometric function is actually quite useful for the engineers and also geologists. Alright. Do you know Hipparchus from, let me highlight. Okay, I'm going to highlight Hipparchus from Nike was an astronomer. He was an astronomer and mathematician. At the same time, he also mathematician, known as father of trigonometry for his contribution to trigonometry. Wow, this is the father of trigonometry, Hipparchus. He developed a trigonometric table. We have a trigonometric table in his attempt to understand the movement of stars and moons. Right. For more information, you may scan the barcode here and you can learn more about the information about the history. Right? So, okay, let's proceed. So the history of trigonometry is part 1. Is actually talk about the early astronomy and the beginning of a mathematical science. So you can go through the history of the trigonometry, which is very interesting. Alright, so let's proceed to the next one. For this topic, after you have learned this topic, you should be able to explain what is the meaning of unit circle. Okay, what's the meaning of unit circle? Trigonometric function, cosine, sine, corresponding reference angle, quadrant, and tangent. So these are important keywords after you study this chapter. Now let's go through the trigonometric. Now, can you see what animal is this? This is eagle, right? Where is the eagle? Is at Langkawi, right? Alright, so let's study the introduction. Well, Langkawi Island, as you know, Langkawi Island. Okay, let me highlight. known as the River of Kedah. River is one of the tidal stations in Malaysia. A tidal station is built to collect tidal data. Okay, tidal data around Langkawi Island. This data can be used to detect tsunami waves. As tidals occur periodically, such tidal data can be modeled with graph of trigonometric function. Now you can see the trigonometric is so important because it can actually used to detect the tsunami waves. Alright, so let's go through the angle. 6.1. The value of sine, cosine and tangent for angle theta. So you need to know the value of sine, cosine and tangent for angle theta from 0 to 360. Okay, for one circle. The diagram on the right shows a unit circle. So now I want to introduce to you what is unit circle. A unit circle is a circle that has a radius of 1 unit. Now this is a very important sentence. What is unit circle? It's a circle that has a radius of 1 unit and is centered on the origin. The x-axis and the y-axis divide the unit circle into 4 equal quadrants, namely quadrant 1, quadrant 2, quadrant 3 and quadrant 4. It is given that P is a point that moves along the circumference of the unit circle and theta is an angle formed by the radius of the unit circle. By the radius of unit circle, that's a very important keyword. OP, from the positive x-axis in an anti-clockwise direction. So it is found that point P is in quadrant 1 and the angle is 0 to 90 degree. In between 0 to 90, that is called quadrant 1. For quadrant 2, the angle is between 90 to 180. For quadrant 3, the angle is 180 to 270. And quadrant 4, the angle is 270 to 360. So you must know how to define the quadrant. So this is example of the unit circle. As you can see, the unit circle is always come with a unit. Here is 1. The length of the radius is 1 unit. So that means here also 1 unit. So the radius, all the radius should be the same. So this is 1, this is 1, this is 1 and this is 1. All the radius are having same unit. So from 0 to 90 degree, this is quadrant 1. 90 to 180, this is quadrant 2. Right, this is quadrant 2. And 180 to 270, this is quadrant 3. And 270 go back to 360 is quadrant 4. Right, so you must identify the quadrant. So this is quadrant. Okay, let me highlight. This is quadrant 1. Okay, the green one, and then the purple one is here. I'm going to highlight to you. This is quadrant 2, quadrant 2, and the quadrant 3 is, I'm going to use blue. This is quadrant 3, and then the quadrant 4 will be here. This is okay, the quadrant 3 is in blue. Then the quadrant 4, I'm going to use yellow. This is quadrant 4. So we have 4 quadrants, starting from the first one is first quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Alright, so I have introduced to you what it means by quadrant. So now what is the relationship? What is the relationship between the function of sine, cosine and tangent for angles in quadrant 2, 3 and 4 with the corresponding reference angle? What is reference angle? So now for today's lesson, our learning standard is make and verify conjecture about the value of sine, cosine and tangent for angle in quadrant 2, 3, 4 with corresponding reference angle. Sounds very technical. What is reference angle? Let's do the activity mobilization. Okay, so to explore the relationship between the function of sine, cosine, and then the tangent for angles in quadrant 2, 3, 4 with a corresponding reference angle. Now you need to open the file here in GeoGebra. So later I will show you about the activity. So this activity is very good because it actually help you to have a better understanding about the reference angle and also the relationship between the reference angle and the quadrant. So we need to drag the point to, there is a red point, can you see that? Okay, let's do the activity now. Okay, we are going to understand what is corresponding reference angle. So you see there's angle 60 there. So the red point, we are going to drag this red point to quadrant 2. Okay, let's drag now. Quadrant 2 will be 90 to 180, right? Observe the blue angle. So if I shift to the second quadrant, the blue angle will have reading there. You can see 120 degree, and the green angle is actually the reference angle is 60. So if I drag to quadrant, let's say I'm going to drag to quadrant 3, so I want you to observe the angle at the third quadrant for the blue angle, which actually here is 220. If you look at that, right, you can see how I rotate. So I'm going to show you right now. You just observe the next. Okay, first of all, if you open the GeoGebra, right? If you open the GeoGebra, okay, let's open it now. I'm going to show you how to. Okay, I'm going to show you how to do this activity. So at first, maybe you are at the first quadrant, let's say 60 degree. Then let's say you shift to another quadrant 2, whereby the blue angle now is 120 and the green one is 60, right? The green angle 60 is the reference angle, the blue one is 120. That means the 60 degrees still the reference angle, but the corresponding angle in second quadrant is 120. So if I move to third quadrant, which is 180 to 270, you can see the purple angle is third quadrant now is actually 40, right? And then the blue angle now is 220. Can you see that? Alright, so if I shift it to the red dot, I'm going to shift to the fourth quadrant, which is 270 to 300. I will read the blue angle is 300 degree, and the angle in orange color is 60 degree. That is actually the reference angle, and the angle corresponding to 60 degree in fourth quadrant is 300. You got it? If you keep on adjust the red point, and then you can read the corresponding angle in certain quadrant. So the slider range of angle can be dragged to change and display the angle. Click corresponding reference angle, right? You can take the corresponding angle in the box there. There is a box for you to take, right? So if you take out, you won't see the corresponding angle, reference angle, but if you take, you can see the corresponding reference angle. That means for 300 degree, the corresponding reference angle is 60, right? If let's say I move to third quadrant, the corresponding reference angle in third quadrant is 60 degree, but you see the blue angle is 240 degree, right? Alright, so let's proceed to the next one. So write the relationship between the corresponding reference angle alpha with the blue angle. So let's write down the alpha with the blue angle, theta in each quadrant. Okay, now we want to write the relationship between the, let's show the relationship between corresponding reference angle with the blue angle. Okay, so let's see the alpha. So if we drag the red point and choose any blue angles in quadrant 2, 3, 4 to complete the table below, use a scientific calculator to do this. Okay, so now I'm going to use a GeoGebra. Let's say in quadrant 1, we have 60 degree. The alpha is 60. Okay, for quadrant 2 is 60 also. Okay, we can use an angle that we like. We can use all the angle is 60 degree. Alpha are the blue angle. With the blue angle theta in the quadrant. Okay, so the alpha will be 60 for the, okay, this is actually the blue angle 60. So the alpha, okay, let's see. Relationship between the corresponding reference angle alpha with the blue. Okay, that means we are going to find the theta. So if I let's say quadrant 1, the blue angle is 60. Of course, the corresponding angle will be 60 also, because this is blue. This is actually first quadrant, right? So if let's say I change to quadrant 2, now if I change to quadrant 2, the theta won't be the same. Okay, the theta won't be the same. Let's try it now. So if I adjust until the second quadrant is 60, the blue angle, which is corresponding, okay, theta is 120. So this is at second quadrant, right? Okay, if I remain 60 but I move to third quadrant, let's do it now. My angle now is actually 240 degree, right? So if I move, that was the third quadrant. If I move to fourth quadrant with the alpha still 60 degree, what is the blue angle in fourth quadrant? Is 300, right? Okay, you understand? So let me try another one. So okay, let's say I stick to another angle. Okay, the alpha, you can use 30 degree. If I use 30 degree as an alpha, okay, let me write down properly. The 30 degree here is the alpha, and then I'm going to start with the first quadrant. So let me adjust. I have to adjust until I can see 30. Now I have 20. I have 40. Okay, let's see. I'm going to adjust to 30. Okay, we need to adjust until you can see 30, so that later it looks like, okay, we stick to 40 because it looks like 40 is easy for me to. Okay, let's say it's 40, so the alpha in first quadrant is 40, so the blue angle is also 40. So now I adjust to second quadrant with a reference angle 40, then I will get 140 if second quadrant, right? So I just change here second quadrant, here will be 140. So now if I change to third quadrant, what is the blue angle? Third quadrant will be, I can see 220, right? Alright, so if I adjust to fourth quadrant, I can see 320 degree. Right, then you are asking to find the value for sine theta and sine alpha, cos theta and cos alpha, tangent theta and tangent alpha. Okay, let's press the calculator. Let's say we do another round. It's hard for me to write. I make it thicker, so 3/2. Okay, this is 3. You can press the calculator to get the decimal. Okay, then sine alpha, I will get 3/2, right? Both will give you positive value. Okay, cos theta, I will get 1/2. For first quadrant, I will get all positive. Tangent 60. You can try to press your calculator for tangent 60. What is the answer? Okay, let's press tangent 60. Tangent 60. You get 1.732. Here also 1.732, right? Okay, if you press a calculator for sine 60, you get 0.8660, right? This one also 0.860, right? Okay, we use a calculator to press, huh? Okay, if you press a calculator, you get 0.8660. This is 0.8660, right? Okay, and then here you get 0.5. Here you get 0.5. Tangent 60, you get 1.732. 1.732. All are positive, right? So if, let's say, we remain the alpha as 60, and then we change to second quadrant, the alpha is still 60, and the blue angle now is 120, right? So let's write down the second quadrant activity. So we will use the blue one. This is 120 now. So if you press the calculator here, still positive, 120, right? This is positive. Sine still positive. Second quadrant. Cos, you will get cos 120. You press the calculator. cos 120, I'm sure you get negative 0 point. You will get negative 0.5. Okay, and then cos alpha, of course, is always positive. Tangent 120, let's press tangent 120. I'm sure you get negative, right? You get negative, only the sign will change. Okay, let's say you change to third quadrant. Okay, we use a green color. So if you remain at 60, so the angle now is 240. So you press the calculator, sine theta will give you negative, right? You get negative. This value will change to negative 0.8660. Okay, the value now turn negative for third quadrant for sine. For cos 240 is still negative, right? Yeah. And cos 60 in first quadrant is always positive. And tangent 240 will give you positive now. This is positive 1.732. So tangent alpha still remain the same. For first quadrant, it will remain the same. Now I'm going to do the quadrant 4. For quadrant 4, you notice that this angle will become 300, right? Isn't it 300? So if you press the calculator, sine 300, you will get a negative, still negative, sine alpha positive. Cos 300 will turn positive now. It will become positive. This one still positive. And the tangent now will become negative 1.732. And this one remains 1.732. So based on the table in step 6, compare the values of the sine, cosine, tangent of blue angle theta with the corresponding reference angle. So we have compare, and we notice that only the sign change. So complete each of the following. Let's write the sign. Okay, if second quadrant is equal to positive, right? Cos is equal to negative, tangent is equal to negative. For third quadrant, sine will become negative, cos will become negative, tangent become positive. Fourth quadrant, number 4. So this is negative, right? Tangent be negative. So for fourth quadrant, cosine will be positive. Let's write down again. Okay, this is positive, this is negative. For fourth quadrant, cosine will be positive, right? Okay, so let's proceed. So the result of the mobilization shows the corresponding reference angle alpha is always less than 90, right? Alpha is always less than 90. Angles in quadrant 2, 3, 4. This is very important. Let's jot down. Corresponding reference angle alpha. Okay, the angle in quadrant 1 itself is the corresponding angle to alpha equal to theta. So for first quadrant, alpha equal to theta. For the second quadrant, alpha is 180 minus theta. Alright, so that is how you read the angle. And then for the third quadrant is 180 plus alpha, right? Or you can say that theta is 180 plus alpha, or alpha equal to theta minus 180. And then for fourth quadrant, alpha is 360 minus theta, or you can say theta is 360 minus alpha. So the reference angle in quadrant 2, 3, 4 are the corresponding angle in quadrant 1. So that is the conclusion. So the relationship between the function of sine, cosine, and tangent for angles in quadrant 2, 3, 4 with the corresponding reference angle can be summarized as follows. So for sine is positive, for cosine is negative in second quadrant, for tangent is negative in second quadrant, for third quadrant tangent is positive, the rest will be negative. For fourth quadrant cos will be positive, the rest will be negative. So then we come up with a conclusion that okay, for the first quadrant all will be positive, and then for the second quadrant only sine will be positive, for the third quadrant only tangent will be positive, and then for the fourth quadrant only cosine will be positive. So that's why we will come up with a conclusion that all sine teacher crazy, or you can say add sugar to coffee, or you can say or whatever you like. Okay, aku suka tengok cicak or whatever, up to you. So you must memorize this one, and this actually telling us which one is positive. So it's actually memorized in this way. It's actually anti-clockwise. Okay, so first, second, third, fourth is following anti-clockwise. So that is how we memorize the angle for sine, cosine, and tangent. Still remember, all sine teacher crazy. For ASTC, you can use your own sentence to help you to memorize all sine teacher cute, or all sine teacher charming. All means all the quadrant for the angle are positive. Sine here refer to second quadrant sine are positive. So this one is meant for first quadrant, this is for second quadrant, this is for third quadrant, and this is for fourth quadrant. So remember, all science teachers are crazy. Bye bye and have a nice day.